In this final video for the week, I will finish up my example on implicit differentiation and do a couple more. We have to look at taking a second derivative using implicit differentiation, as well as writing the equation of a tangent line. So in this last example, I asked you to try to clean this up and solve it for dy dx. In terms of cleanup, the dx's are just 1's, so those are gone. So really I've got 2x plus x times dy dx plus y minus 3y squared dy dx equals 0. And I want to isolate this term and this term, I guess with the negative in it, which I missed. But we want to isolate those terms because they've got the dy dx's in them. So I'm going to take the 2x and the y and I'm going to move them over to the other side. So keeping the dy dx terms on the left, moving the other terms to the right, this is what we've got. Sorry, I just looked up on my computer and noticed that it had paused for some reason, so I hope that didn't cut you off and we can just pick up from what we have right now. Anyway, so we are going to need to now isolate these actual variables. We isolated the terms, let's isolate the variables. Anytime you have the same variable in multiple terms, you'll want to factor it out. So if I factor out a dy dx from both of those terms, the last thing that I'll need to do is to divide in order to get the dy dx all by itself. So dy dx will equal negative 2x minus y. Whoops, I put in a 2y there. Should just be a 1y. All divided by x minus 3y squared. So it looks like that is our derivative. Negative 2x minus y over x minus 3y squared. So let's say that we wanted to write the equation of the tangent line. Which is a common theme in every section that we do. Not just find the derivative, but use it to write the equation of the tangent line. So write the equation of the tangent line for, sorry, I'm not writing this properly, x squared plus xy minus y cubed equals 7 at the point 3, 2. So we should know by now that we need, of course, a slope. And we need the slope at the point 3, 2. And then we need the point itself in order to use the point slope formula that we've been using. So the point was given to us. That's not going to require any work. But let's think about how it is that we would get the slope in general. And the slope in general is going to be our derivative, our dy dx. Luckily, we just found that. So instead of redoing all the work, I'm just going to copy the same derivative that we found a second ago. But I also need to evaluate that at the point 3, 2. So remember I referred to that notation, sorry, I referred to that notation last time, which means just evaluate at the point 3, 2. And so remember that means that we need an x to be 3 and we need a y to be 2. So because these aren't functions, the derivatives have both x's and y's in them, and we need to substitute both values. So I'm plugging 3 in for x and 2 in for y in order to get my slope or my derivative at that specific point. So on the top, that gives me negative 6 minus 2, which is negative 8. And on the bottom, I get 3 minus 12, and that's negative 9. And simplifying that gives me 8/9. Alright, so I have my slope at that point, and now I need to write the equation of the tangent line. Y minus 2 equals 8/9 times x minus 3. And we're done. So the only thing different here that we hadn't done in past sections is when we're evaluating at the point, we're not just plugging in an x value. Our derivatives have x's and y's in them, so we need to plug in both values. Alright, I'm going to finish off here with a second derivative using implicit differentiation. So I'm looking to find the second derivative. And here's my example. Another non-function with x's and y's. And so of course, in order to find the second derivative, I need to find the first derivative. It's always important to identify which variable you're taking the derivative with respect to. So some of that notation coming into play here. The second derivative notation looks like this, d squared y divided by dx squared. So this means I'm taking the derivative with respect to x. And in fact, it's going to be the second derivative. So the first thing I need to do here is I need to find the first derivative. And notation-wise, that will be dy dx. Let's find the derivative of each term. 2x squared, use the power rule, which will be 4x. Use the notation showing which variable you took the derivative of and which variable you were taking the derivative with respect to. Do the second term. Derivative is 2y dy dx. And then finally we have a constant whose derivative is 0. dx is just 1. This is the variable I need to solve for. So I'm going to take the 4x and I'm going to move it to the other side of the equation. 0 minus 4x gives me negative 4x. And then finally let's divide. There we have the derivative dy over dx equals negative 4x over 2y. That can be simplified in terms of the constants, 4 divided by 2. So negative 2x over y. That's our first derivative. I'm boxing it even though it's not our answer. But if we need a second derivative, we need to start with a correct first derivative. So there we have it. Let's keep going. And let's find that second derivative. This notation is a little bit harder to get used to than some of the other ones in the first third of this course. So the d squared y over dx squared is the second derivative. And you'll work with it and you'll become more familiar and get used to it. So anyway, so we're taking the derivative here. Of the first derivative, taking the derivative of the first derivative in order to get our second derivative. So let's start by taking the derivative of the left side, and all that requires is that notation. So we took the derivative there, and we get d squared y over dx squared. Now we want to take the derivative of this side with respect to x. And in order to do that, we do need to use a quotient rule. So we've got the low, d high. So here we're taking a derivative. The derivative of negative 2x is negative 2, but I need to show the variable that I took the derivative of with respect to which other variable. So dx over dx. Alright, so don't get lost in your quotient rule. That was low d high. Now I need minus high d low. And for d low, I need to take the derivative of the denominator, which is 1, using my implicit differentiation notation. Derivative of the variable y with respect to x. The whole thing is divided by low y squared. That needs a little cleanup.